Hi, this is Henning from FlippedNormals.com, and in today's video we are going to be covering skin shading in Maya using Arnold. Before we get into that, if you want to learn how to create this character from scratch yourself, we have a full masterclass for that, covering how to create a whole character from the sculpting in ZBrush to the retopology, to painting maps in Painter, to rendering the whole guy, and really covering everything start to finish in realistic character portrait masterclass. Before we really talk about skin shading though, we have to talk a bit about modeling and texturing. So let's jump into ZBrush. This is what the final model looks like, and I can't stress enough how important it is to have a good model. There are a few reasons for this. The first one is that if you have a good model with all the pores and everything like this guy here has, then the material is simply going to respond a lot better. If you don't have high frequency details, it's really never going to look realistic, at least not if you want to look like skin. Now, you don't have to do this in ZBrush. You can do this in Mari, Painter, or in ZBrush. This depends entirely on your personal workflow. In this case, the details were done in ZBrush, and they are being exported out through a displacement map. What you also have to keep in mind is you need your model to have correct thickness. For instance, here with the ears, this is not perfect, but you can see here the ear is quite thin. The ear is going to be covering this whole area. So there's one big potato here. Then the SSS is not going to work as expected. It's the same thing with the eyes as well. You want this to have approximately the same thickness throughout as it is in real life, and same with the nose as well. If this is clogged, it's not going to look realistic when it comes to SSS. You also want to be sure to have nice mid-frequency in your model as well, because skin shaders can only improve what's already there. It can't create new things. So with that said, let's move on to textures. Here we have the final texture maps in Substance Painter, and we really only have three maps here. We have a color map, then we have a roughness map, and then we have a scattering map. And with these three maps, you can really create very realistic characters. The color map only has the color information. There's nothing really baked into it. You can see that we have a tiny bit of the displacement map in here just to enhance some of the wrinkles, but this is more dirt than anything else. You want to be careful to not have too much ambient occlusion or cavities or anything like that in here, because that's not going to respond correctly. For instance, if you have a lot of lighting information baked into your model and then the lighting in the shot is completely different, it's going to look really weird. Then we have the roughness map, which is also very simple. We have a little bit of the displacement map in here as well, a little bit more than the color map. And here you can see certain areas are darker than the others, and dark simply just means smoother, which just means more reflections. And then lastly, we have the scattering map that indicates where there's going to be more or less scattering. You can see these maps are quite simple. Often, you don't really need a whole lot of work in these kind of maps. The biggest mistake I see people do when they are texturing and look deving is that they're treating this as a linear process, which means that you start off in textures right here, and then you immediately, once you're done with this, you throw this into look dev, and then you throw this into render, and it's a linear process. The problem with this approach is that you finish your textures and you put this into look dev, and then you do your look dev and you put this into render, but there's no feedback at any point. You don't know if what you're painting here is going to work before you see it in look dev. So this means that if you are working with textures like this, you're gonna have to put them into look dev very early on. So create some base textures, put them into look dev, and then you can get feedback on that, then throw them back into textures and just keep this loop going. Then once you finish your look dev, you can put this into render where you're doing, you're setting up the lights, environments, everything there, and then you might do adjustments based on that, just to be sure that everything works together. You might have to do texture adjustments based on the shot as well, just because lighting changes. Obviously, you don't want to do bespoke shaders per shot, but at least you get more information on that. So start with something simple in textures and get it into look dev early on and keep working with this. That's how we came up with values like this. That looks quite simple, but it's very balanced. If you work this way, your shader setup in Maya can honestly be quite simple. You can get away with only using a few simple nodes. So with this said, let's jump into Maya and let's get started with our skin shading. So here is the starting point for this video. We already done the eyes using the FlippedNormals eye kit, and we have some simple lights here as well that shows a little bit of rim light here. We have a little bit of light on the ear, so we can test the SSS there as well, but it's also very neutral. It's not a lot of color in the lights. We're also using an HDRI as well, just to get a bit more variation in the specularity as well. In terms of the scene, it's very simple. We have the eyes, which are the FlippedNormals eye kit, the head, and then we have the horns. We are only going to be doing the head today. So the first thing we're doing is we are going to be setting up the displacement map. This has been exported out from ZBrush. So we are going to simply just remove the additional settings here. So the first step is to select our model. Then we go to the shape node. We have a transform node, which just has the transforms, and we have a shape node that actually changes the settings for the shape. Then under Arnold, you just want to open up Arnold, and then you just want to go to subdivisions, and under type, set this to Cat Clark. I'm going to be using 3 as a setting right now, which just means that at render time, this is going to be rendering 3 times, which means that this is a subdivision level 3 model. It's going to go up to level 6. Then we want to go under displacement attributes and just be sure that scalar 0 values is set to 0.5. This is because my displacement map has a mid value of 0.5. If your disp has a mid value of 0, you set this to 0. Then under auto bump, just be sure that this is enabled as well. This means that if whatever is not going to be in the displacement, it's just going to be in the bump. So like very fine details and such. Then we go under the material. I just have a very simple material assigned here. This is just the standard surface, and I've just named this to head mat. Then we go to the displacement material, and under here we just go to file, and then under the displacement value we just input the disp, the C disp, just indicating it comes from ZBrush. Change the tiling mode to UDIM, set the color space to raw, and now if you render, just do a little save first because this might crash. Then we just hit render, and now this should work correctly. So I'm expecting this here now to have be a high-res image, and it's going to have all the little details and such, and that is exactly what's happening. So setting up a displacement map is quite simple once you know the steps. Essentially, it's broken down into 2 tasks. The first task is you have to apply essentially a displacement setting on the mesh. It's telling you to subdivide the mesh at render time, which is very handy because this means that we can work with a very low poly model in the viewport, not very, kind of low poly, and we can have a very high poly model in the render. And then the second part is to us actually plugging in the texture map, into the actual displacement map into it. So cool, now we have a good starting point here. So what we're going to be doing is we're just going to be cancel this one here, and then we're going to open up the Hypershade, which we have open right here. So once we have the material, we can just hit the input. We don't necessarily need anything else for this right now, and then we just want this one. Then we are going to create a file node, just create texture right here, and this is going to be our color texture. So just go under image name and select the color map here. This is exactly the same one we had in Painter. And then we are going to be plugging this under Subsurface, which is a little bit different than what you might have done before. You might have plugged this into the base color, meaning the diffuse, but we're going to be plugging this into the Subsurface. So go down to Subsurface right here, and then we are going to simply just drag this under the color right here. Also, I just need to disable the weight. That's something we're going to be talking about a bit later on. So I just input the wrong one, input the material into material. So we are just going to have to be sure that this is set correctly. So file and just drag this under subsurface color right here. And if you render now, nothing is going to happen. And the reason for this is that, meaning it's going to look exactly the same. The reason for this is we don't have any subsurface active. So we have to change that. Set the weight to 1, and now you're going to see subsurface. But it's going to look weird. So we will definitely have to do some changes to this as well. So there are 2 main changes we're going to have to do right now. The first one is, let's just stop this one. The first one is we're going to have to change the method of subsurface. So this one is using random walk. We need to use random walk v2. This is just a better model for subsurface. Now, if we were to re-render, it would look still fairly similar, but at least we have a model that works a bit better. Now, the second thing we have to do is we need to go under the radius. If this is set to 1, meaning white, it means that the subsurface is going to be active, and if this is set to black, meaning 0, this is just a value, right? Like 0 just means black, and white just means 1. So now you can see there's no subsurface whatsoever to speak of. But what we can do is we can use this color here as subsurface. So what I prefer to do is to go under HSV, and then just picking a color that we want to work with. So you first have to pick a general value. The reason you want a general value is because this essentially indicates how much subsurface you want. So I usually pick a pretty dark and orangey value. So this means that we're going to have still a fair bit of subsurface in the render, and it's going to be orangey reddish. If this is, for instance, were to be blue, you should now start to see that the subsurface in here is going to be blue. So that's obviously not what we want, but this is how it works. The brighter it is, the more subsurface there is, and the hue and saturation indicates what color it actually is. So if you're doing something alien or like this, or something like that, that's going to work quite well. So we want to just stick to something like this. This is not to have a perfect setting right away, because we're going to have to modulate this with the radius map, the scattering map that we created in Painter. So we probably want to make this a little bit darker, but again, doesn't matter a whole lot right now because we are going to have to modulate this with the maps from Painter. Then we're going to need to input a roughness map. So we're going to do the same thing as before. We are going to hit tab and we're going to type file. Then we're going to go to texture. And here we are simply just going to be inputting this. So just pause this one here. And then this needs to be set to raw as well. And then we just select our spec R. Now, what I prefer to do for spec R is I prefer to input an AI range node right away. The reason for an AI range node is that this gives me a lot of extra control. So if you, by default, nothing is going to happen. But if you want to change your roughness later on, then you can very easily change this, right, using these values right here. And then we need to output this into the, plug this into the specular roughness, but you can see this is red and this is green, which means they're not compatible. But if you open this up, you can see we have any one of these channels. We just can take the out color R and put this under specular roughness. The reason we just need to put the R, it doesn't really matter if it's R, G or B, just red, green or blue. It's just because it's a single channel and this is just a single channel, meaning that this here is just a value and this is just a value. So now if we do this, now if we do a render, we should now see that we have some changes to our roughness. Just making sure this one here, this was way too strong now. So just making sure this is set to utility, raw, and now this should be much rougher. So it was far too smooth before. So now you can see that we have roughness in the correct spots. If you want to change the roughness amount now, there are two main ways you can do that. The first one is you can change the actual map itself, just where it's painted black here and like white in certain areas, just so we can modulate that or change that in the material. Or the second thing we can do, we can go into the actual model itself, into the pores and the fine details, and then we can just smooth some of those out and balance those out. If, for instance, you see there's a lot of roughness up here, or rather there's a lot of reflections up here. If you want to remove that, if you were to go over this with like a noise brush or something, this would be much rougher right away. And you can also see there's an issue down here, which means one of our maps now doesn't have the UDIM tag enabled. So let's go through here and just make sure that we have the UDIM tag enabled on both our texture maps. And we have them on neither, which is a mortal sin. We definitely want to be sure that we have the UDIM tag enabled on both of these guys. And you can see how close we can actually get to a decent result simply by using two inputs. And this is because we've already art directed this quite a lot beforehand. This is what we do in the realistic character portrait masterclass. There was a lot of back and forth between going into Lookdev and into Painter. So if you have that, you don't necessarily need a lot of nodes. You see this a lot where you have shader networks people have made, and there's just a huge network. And that's not necessarily a bad thing. That means that you can either do a lot of Lookdev in your 3D software, meaning in this case in Maya, in the Hypershade, or you can do it in your texturing software. At the end of the day, you're just changing pixels around here. So if you were to use some kind of procedurals to break this up, that's practically the same as using procedurals to break this up in something like Painter or in Mari. But there are just different ways of working. I far prefer to work in the texturing software because they are control it more. It's a lot easier for someone to pick it up as well, and it's just simple in the sense that it's data, right? It's just maps being output from this. While here you can have a lot of fancy math nodes and such. So this is a very powerful way of working, but we still need some more control with this. So what we're going to be doing, we're using an AI layer node, and this is going to be in RGBA, which means that we can have the different layers in here as RGB. So we are now going to put this under the subsurface radius slot. So actually, let's just move this up a little bit like so. And then this is going to go under the radius. And the moment you do this, this render is going to look terrible again. So just bear with me. So this goes under the radius. And what we're doing now is we are going to be controlling the color of this using the layer node. So the first one here is going to be the actual color. This is going to be similar to what we have. So we can just color pick this one. And the second one is going to be using the scattering image we made before. So just type file, tab file, texture, and then you just find the texture map you want. Just doing a little bit of a cheeky save. Then we go under our maps, and then we pick our scattering map. And this should be a raw map because this is a utility map. And then tiling mode, Mari, and then we just plug this into the second one. So enable layer and then input right here. And now if we were to preview this, if we were to just render this now, what you would see is that should look fairly similar to what you had before. It should actually look exactly the same as what you had before. So now you might be thinking, well, is this not working? Is the scattering map not working? Or maybe it is working and you just didn't pick it up. Well, there's a very easy way to check that. You see this guy up here? Very, very, very useful button. This is where you can isolate what you are actually working on, or rather the node that's selected. So if you click this one now, you can see what this does. So now you can see this one here just shows the file node. This shows the texture map. This shows the range node. You can see here there's no difference, so it doesn't do anything. We can look at the material, or what we can do now, we can look at the layer node. And indeed, nothing is happening. And the reason for this is that the operation is set to over, which just puts it over, so we need to multiply this. And now you can see this is changing. So this is where you actually have feedback on it. Now you can see that some areas are darker, some areas are brighter, and now you can start to change this. This is why we weren't too specific with the values beforehand. This is more just a first pass, just to make sure that it's working. Whenever you look at them, you don't necessarily want to overcomplicate things in the beginning. You want to keep this quite light and quite simple. Obviously, this is quite light and quite simple, but it's very, very easy to overcomplicate this, particularly early on. So what I'm going to be doing now is I'm going to be cheating, and I already solved this beforehand. So I'm just going to be color picking this beforehand. This is what a lot of look dev is about. It's about finding specific values. So what happened here was that this was a little bit more towards red and a bit more saturated and a bit brighter, just meaning we have a bit more color here. This is what it's just a lot about, where you're just going back and forth and trying out different results. This may not be the perfect result, but at least this is what I found beforehand. And then we can just reduce the opacity of this just a little bit as well, just to have a bit more subsurface in all areas. But then what's important is that you just need to do test renders. You just have to let this thing go for a bit and just test render the whole thing so you can actually see what's going on. So I'm going to just leave this for a bit now while this is rendering, and then through the magic of editing, this will take no time at all for you. And there we go. This took about 40 seconds, which is pretty fast. I'm using GPU for rendering here. Still a lot of noise, but that's totally fine. So the advantage of this now is that we can actually have a bit of a conversation how to improve this. Obviously, we need to add textures to the hordes that we're not doing here, but that would be something you need to do in order to get a first pass. So how I would improve this further would be that I would balance the scattering more. For instance, I like what's going on here. I like what's going on here, but this is too strong. So I would paint more black in this area, paint a bit more black around the mouth, I think, as well, around the lips, because they're very scattery right now, and maybe just reduce it a tad around here. I'm not going to be doing this in this video since the point still stands. This is not about perfecting this look dev here. It's more about showing the approach to it. But we're also missing one important thing, that is the coating. The coating is a layer on top that's often used in car paint shaders and general plastic and such, where you have a general layer of specularity, which might be a bit duller, and then you have another coat on top, like an actual layer of paint on top of it. That can be very beneficial for adding more specularity to it. How this will work for skin would be that, for instance, if you have a layer of sweat or something on top, it can be really nice to add a layer of coat. So we can just save this layer right here, or save this render right here, and then we can go under our head material, and then we can enable the coat. So just enable the render again, and then set the coat value to 1. So if we now were to go under an AOV, I created some AOVs for this. If you don't know how to do this, you need to go to AOVs and then just add the AOVs right here. So I have a specular AOV and I have a beauty AOV and a coat AOV as well. So now you can see these two as well. So now you can see that here, if we have the coat enabled, now this is going to, well, be enabled like this. And if we were to change the roughness, this were to be broader like so, then this would be more rough, and if the value goes down, then this is going to be smoother. So you want to be careful when making this too smooth, because the character is going to look crazy shiny. So you don't necessarily want that, but you want to play around with these values a bit and just try to get another layer of spec. You can also use the roughness map as well we created to control this more. You might even have a whole separate one as well, or you might want to use something like clouds or something just to break that up a little bit as well. For this, we are going to be using a value of around 0.3, which is going to work quite well for this. So I'm going to be doing 2 renders now, one with coat and one without coat, and you can see the difference. You're going to see a fair bit of difference on like the sheen around him here. It's just going to look a little bit nicer. I've also changed the IOR as well down a little bit. This is, I believe, 1.5 as a default one. So let's do the renders. So here you can very clearly see the difference between with coat and without coat. With the last one is without, and this is with, so with and without. So you can see there's a lot more like integration here. It's also a little bit more in the face as well. We can see just a little bit more here, but also just a little bit more around the face as well. So coat is quite nice. I haven't balance this properly either. This is more just enable it and see where it goes. This is definitely something you can balance a lot more if you want like broader reflections in one area, but on top of this you want sharper reflections. Let's say you have this area here around the eyes, for instance, where you do have like general broader reflections because there's still just general greasiness in your face, but you around the eyes, for instance, you might want some very sharp reflections indicating that there is like moisture around here, for instance. So there's a lot of stuff you can do with that. And then I just want to make you aware of one little setting as well that's quite useful. That's under Arnold render, advanced. So it's on the sampling advanced, and then use auto bump and SSS. This is very useful if you're using the actual auto bump feature as well, and you're using SSS, it's just going to appear in the SSS, as I guess the name implies. So that's really it for the skin shading of this character. It's quite straightforward when you're really getting into it. This is the final setup for this, where just to sum this up, we aren't really using diffuse, we're just using subsurface right away. So under subsurface, we have the scattering map plugged into a layer node that goes into the radius that allows us to really control the scattering. Then we are using the color map under the color directly, and then we're using some coat just to break up the specularity a little bit more. And then under specular, we are using a roughness map under roughness. And it's quite a simple setup. For displacement, we're also just chucking that directly under the shader group as well. One last little tip that might be quite useful for you as well is you can input the file node under the base color as well. So under the color and base color here as well. Now this is not going to change anything. So for instance, if you were to do a render now, nothing would change because we haven't enabled any diffuse. But now if you were to go under subsurface, for instance, now you can, if this is set to 0, now there is no subsurface whatsoever. This is all diffuse. And if this is set to 100 or 1, then it means it's all subsurface and no diffuse. So if you want to reduce globally the subsurface, you can, for instance, set this to like something like 0.8 or something now. Now you have a little bit less of the subsurface, a little bit more diffuse, and this can be a handy way of balancing that as well. So yeah, that's it for this video. I highly recommend you look into the full course as well, Realistic Character Portrait Masterclass, which is going to teach you how to do this whole thing from scratch. We also have tons of other videos about Substance Painter, about Maya, Blender, ZBrush on our YouTube channel as well. So feel free to check those out, and we'll see you in the next video.